Hello, my name is Alia Amin, and today I'm going to present a seminar on data warehousing and online analytical processing. First, let us see what is data warehouse. A data warehouse is a type of data management system that is designed to enable and support business intelligence activities, especially analytics. Data warehouses are solely intended to perform query and analysis and often contain large amounts of historical data. And data warehouse provides architecture and tools for business executives to systematically organize, understand, and use their data to make strategic decisions. Many people feel that with competitive mounting in every industry, data warehousing is the latest must-have marketing weapon, a way to retain customers by learning more about their needs. Let us take a closer look on each of the characteristics of data warehouse. First is the subject oriented. A data warehouse is organized around major subjects such as customers, suppliers, products, and sales, rather than concentrating on the day-to-day operation and transaction process of an organization. A data warehouse focuses on modeling and analysis of data for decision makers. Next is the integrated. A data warehouse is usually constructed by integrating multiple heterogeneous sources, such as relational database, flat files, and online transaction records. Data cleaning and data integration techniques are applied to ensure consistency in naming convention, encoding structure, attribute measures, and so on. Next is the time variant. Data are stored to provide information for an historic perspective. Every key structure in the data warehouse contains either implicitly or explicitly a time element. Last is the non-volatile. A data warehouse is always a physical separate store of data transformed from the application data found in the operational environment. Due to this separation, a data warehouse does not require transaction process, recovery, and concurrency control mechanism. It usually requires only two operations in data accessing, that is initial loading of data and accessing of data. Now let us see some of the needs for data warehouse. First is the business user. Business user requires a data warehouse to view summarized data from the past. Since these people are non-technical, the data may be presented to them in an elementary form. Second, store historical data. Data warehouse is required to store the time variable data from the past. This input is made to be used for various purposes. Third, to make strategic decisions. Some strategies may be depending upon the data in the data warehouse, so data warehouse contributes to make strategic decisions. Fourth, for data consistency and quality, bringing the data from different sources at a common place, the user can effectively undertake to bring the uniformity and consistency in data. Fifth, high response time. Data warehouse had to be ready for somewhat unexpected loads and types of queries, which demands a significant degree of flexibility and quick response time. Now, let us see some differences between operational database system and data warehouses. Most of the people are familiar with commercial relational database systems. It is easy to understand what a data warehouse is by comparing these two kinds of systems. The major task of online operational database system is to perform online transaction and query. These systems are called online transaction process system, that is OLTP. Next, the system which can organize and present data in various formats in order to accommodate the diverse needs of different users. These systems are known as Online Analytical Process System, that is OLAP. The major distinguishing features of OLTP and OLAP are summarized below. First is the user and system orientation. An OLTP system is customer oriented and is used for transaction and query processing by clerks, clients, and information technology professionals. An OLAP system is market oriented and is used for data analysis by knowing knowledge workers, including managers, executives, and analysts. Next is the data content. An OLTP system manages current data that typically are too detailed to be easily used for decision making. An OLAP system manages large amount of historic data, provides facilitate for summarization and aggregation, and stores the managed information at different levels of granularity. Next is the database design. An OLTP system usually adopts an entity relationship, that is ER, data model, and an application-oriented database design. An OLAP system typically adopts either a star or a snowflake model and a subject-oriented database design. Next is the view. An OLTP system focuses mainly on the current data within an enterprise or department without referring to historic data or data in different organizations. In contrast, an OLAP often spans multiple versions of database scheme due to the evolutionary process of an organization. Next is the access pattern. The access pattern of an OLTP system consists mainly of short automatic transactions. Such a system requires concurrency control and recovery mechanism. However, access to OLAP systems are most read-only operations, although many could be complex queries. Other features that distinguish between online transaction processing and online analytical processing systems include database size, frequency of operation, and performance metrics. Some of the comparisons of online transaction processing and online analytical processing systems are shown here. Now let us see the architecture of data warehouse. Data warehouse often adopts a three-tier architecture as presented in this figure. First is the bottom tier. A bottom tier is a warehouse database server that is almost always a relational database system. Backend tools and utilities are used to feed data into the bottom tier from operational database or other external sources. These tools and utilities perform the data extraction, cleaning, and transformation process, as well as load and refresh functions to update the data warehouse. The data are extracted using application program interface known as gateway. A gateway is supported by the underlying DBMS and allows client programs to generate SQL code to be executed at the server. Example of gateway include ODBC and OLEDB, that is Object Linking and Embedding Database by Microsoft, and GDB, Java Database Connection. These tiers also contain a metadata repository which stores information about the data warehouse and its contents. Next is the middle tier. The middle tier is an OLAP server that is typically implemented using either relational OLAP model or a multidimensional OLAP model. Next is the top tier. Its top tier is the front-end client layer which contains query and reporting tool, analysis tool, and data mining tools. From the architecture point of view, there are three data warehouse models: the enterprise warehouse, the data mart, and the virtual warehouse. An enterprise warehouse collects all of the information about subjects spanning the entire organization. It provides corporate-wide data integration, usually from one or more operation system or external information providers, and is cross-functional in scope. It typically contains detailed data as well as summarized data and can range in size from few gigabytes to hundreds of gigabytes, terabytes, or beyond. Next, the data mart. A data mart contains a subset of corporate-wide rate that is a value to a specific group of users. The scope is confined to specific selected subjects. Data marts can be categorized into two types, that is independent and dependent. Independent data marts are stored for data capture from one or more operational system or external information providers, and dependent data marts are sourced directly from enterprise data warehouse. Last is the virtual warehouse. A virtual warehouse is a set of views over operational database. For efficient query processing, only some of the possible summary views may be materialized. A virtual warehouse is easy to build but requires excess capacity or operational database service. Thank you.